My name is Lautaro Paquevicius, and this is my attempt at the Connect Challenge. The Connect4 Challenge is a classic game with 6 rows and 7 columns. The goal here is to align 4 tokens in any of the winning conditions. To do that, we're gonna first use an array of arrays to mold the board. We need to do an empty field first because otherwise we'll get shallow copy error. And then fill as intended. We're also going to have a player which we will toggle on every turn, and we'll have a winner by the game. We're going to have 3 startup methods: print, play, and checkWinner. The play method will receive a column, and the checkWinner will receive. We're going to call checkWinner on every game. We don't want to get too far ahead without testing our stuff, so I'm going to start 4, and I'm going to print. This is very easy then. On index.js. Input stop table is stop board. Great, that's looking good. So for the play, I'm gonna go for the given column. I'm gonna go from the bottom to the table up because we're gonna pile stuff. For stuff, I'm gonna check the column is valid. That means it's less, it's bigger than 0, sorry, and it's less than the max columns. If it isn't, then I'm gonna return. And also I'm gonna check that I haven't won. If a player has won, I'm gonna return something like this. And well, the play, as I told you, goes like this. If I don't see any free spots, then I continue until I do, or I leave without doing anything. If I'm here, it means that I'm assigning this player to this place. Then I'm gonna print board just because it's easier for us to debug. Then I'm gonna check if the user won, and then I'm going to return. Great, this is what we aim to have. I'll check this piles on. It doesn't. What am I missing here? In this board, print, play. In every play, we check this. Hmm. 0 and 0, colon, some colon. Oh. That's about it. Oh, and we need to toggle the player. Almost forgot about it. We'll do this at the end. Else it's 1. Cool. This should work now. Great. So far, so good. For the checkWinner, I'm gonna go for every cell, checking if I find a value related to the current player. And if I do, I'm gonna do a recursive call following the delta. What is a delta? They're the winning directions. There are 4 of them. We're gonna start with that, and then I'll continue explaining my idea. I'm gonna do an array of objects, which will look like this. Y0, 4 of them, 0. The first one is the horizontal, the second one is the vertical. This is a down diagonal, and this is the up diagonal. Great. And what I'm gonna do, as I told you, is I'm gonna go row for row with a good old matrix loop. And a row should be less than this. Plus plus. Right. Cool. And then I'm gonna copy this. We pray fall into a typo here. Ooh, we have our loop. And here I'm gonna check something similar, but this time looking for a value associated to my player. If it's not my player, then we'll continue. And if it is, we're gonna do what I told you. I'm gonna step on the cell, check on the directions I care, and if I get a winning condition in any direction, I'll return true, and the game ends. How do I do that? I'm glad you asked. I'm gonna do this, and then I'm gonna map every delta with this function, which I'm gonna create right now, and then I'm gonna reduce it with an OR. I hope you're already getting the idea. You'll get it. And if I win, I'm gonna assign winner to this player. I'm gonna print something. Stop count 1. Cool. That looks great, actually. What is follow delta? Typo there. Fix it before I get it. Follow delta is a function that recursively calls itself, tracks the count, as a delta. For every recursive function, we need to quit early on the tails. So we're going to do that. We're going to check first off what we heard about. If we have reached 4, then return true. If we are out of bounds, how we're going to do that with another function is valid. Actually, it isn't valid. Return false. And well, if we are stepping on another player's position, it means that our path is ruined and we are returned false. And then we do the recursion, follow the delta row plus the direction we're going. Y a plus 1 to the counter because we validated that we are stepping in a position of ourselves. And the delta, which doesn't change, because of that we don't need to check for it. The tails is valid. We'll take a row and a column, and we'll check we're not out of bounds. Basically, it's a simple try catch. That returns false if something crashes, or returns verifying that it's not undefined. So if this count 4 is not valid, or if not our place, return false. Return false, and true if it reaches 4. And we're back here. This is the final bit. Actually, we are stepping in already a place of ours, so we need to let them know that the next delta is what we care about. Dx, dy, we're stepping in 1, and we are going in this direction. This will basically map a solution for the 4 directions, and this should work actually. We play, we print, we check the winner. Cool. I'm confident in this. And let's copy this 3 times. Player 1 should win, right? Oh, no, my bad. I'll do this, get this. We already have a winner, but we'll let the player 2 think that he has a chance. Great. As you can see, we played, and number 1 reached the place top count. Number 1 won, and the last play was rejected because player 1 already did so. Well, this was my attempt. I hope you liked it.